added this to 9-4. I guess I shouldn't have. If you'll remember, like I said, I teach at a couple different books, and I guess I got mixed up. This one separates these two. The other ones do it in the same section as when we're talking about mid-segment and that kind of stuff. Okay, you guys remember when I talked about when you have three parallel lines? They get broken down into proportional parts when you draw two transversals the same way triangles do. This is X, this is Y, this is A, this is B. What proportion can I write? X over Y is equal to what? A over B. Easy peasy. Agreed. It will always work out like that. The other thing that they say here, and I'll draw a picture for it down here while you guys are writing that down. Those of you that have been absent, you're absent Monday. The reason we're going through this quickly is because it's same thing. We did talk about that. Now, we didn't talk about this. We talked about this already, how when you have three parallel lines, it's just like when you have parallel bases, when it breaks a triangle into proportional parts. Excuse me, I'm sorry. Same thing happens when you got three parallel lines and they don't quite make a triangle. These parts created are congruent. Or not congruent, but proportional if these three lines are parallel. Put the phones up, please. Tried to here. What do you think I tried? What do you think of the difference between these three? They look like they're parallel, correct? What else do they look like, though? How would you describe how they relate to each other, you think? You can't say congruent because all parallel lines are congruent, but you're thinking the right thing. What are you saying? So how would you say that to me?
They're similar.
No. What are you seeing that's the same?
Width?
Somebody give me a piece of notebook paper. Let me see a piece of notebook paper right here. Let me see one of yours. I got some right here. Hold on. Okay. That's notebook paper, right? Isn't that a bunch of parallel lines? What's significant about those parallel lines, though?
They're equal.
Well, they're not. They're what? When you say equal, what are you really trying to say? They're the same distance apart, right? You see what I mean? That's what I was trying to get you guys to say. These are a bunch of parallel lines that are exactly the same distance apart. Now, when I draw a line, no matter how I draw it, what does it look like? What's going to happen here? Is that always going to be congruent to that? No matter how, now, the parts are still proportional, but I mean, I could draw this really weird line like this. Look what happens. What do those spaces look like they are? Doesn't this look like it's congruent to that? You see what I mean? You can really see that on a notebook paper. Can I write on your notebook paper? Okay. Do all those segments created look like they're the same? Look, me do this. All the segments look like they're the same?
Yeah.
No matter how I draw it, no matter how sideways I kind of draw it, doesn't here to here look to be the exact same distance from here to here, and so on and so on. That's what the other theorem says in this section, that when you have three parallel lines or more, no matter how you draw a line, it's going to be, you're going to cut these three parallel lines, you're going to cut it into what? Congruent parts, right? Everyone agree? So that's the other theorem from this section. Doesn't matter how I draw it. Everybody got that? Freeze that for a second, for those of you wanting to write it down. All right, now, so let's get out our worksheet. What do you think they're going to have us do here? We're going to just recognize the proportional parts here, are we not? Can I unfreeze this?
Yeah.
Okay, first one. Let's get zoomed in to where PQ. Here are our three parallel. PQ over what? QR. Well, equals what proportional parts go with that?
ST.
Over what? TW? So what should this be? ST? Here, TW over ST. So we went TW to ST. So what would I need to do over here? RQ to what? PQ. Or so QR? QR or RQ, right? What about right here? PQ over P,
SW.
PR would be ST over what? Very good. TW over SW would be, what does it need to be on top here? QR over PR? See how as long as your parts are congruent, or I'm sorry, proportional, it's the same corresponding part. SW over ST, SW, ST. What would need to be over on the other side? The whole thing, which would be?
PR over PQ.
Yeah. I just can't write today. So this one, PR, that's the whole thing over QR, would be the whole thing over here, which would be SW over what? TW, right? Because you just got to see if the one they over corresponds, they need to correspond, right? That's pretty easy, isn't it? We go down to 10. What's our proportion going to be to solve for x here? 10 over x is equal to what? Cross multiply. 120 is equal to 8x. Divide by 8. What's x equal to?
Every time I look, I'm just looking over here. Nothing. I don't.
Am I going too fast?
No.
Well, then what are you griping at me
I
about?
was talking to someone else. Is there,
About
not you.
me?
No. I think
What is
about-
120 divided by 8? Everybody's picking on poor Coach Stone. Think we can do this one? 3 over 6 equals 4 over x, right? Let's go to one a little bit. Okay, what could you do here to make life a little easier on you? What's that? So I would go 14 over x, quiet please. 14 over the whole thing x is equal to what? 15 over the whole thing, 30. Everybody good there? This one would probably easier to go what? 10 over 12 is equal to what? X over x plus 2? Okay, we good? Okay.